Whoa, everything's different. This is so cool. And we are live. Let's see. Am I hearing myself? No. Okay. All right. So Pamela, will people be able to hear your disembodied voice as we talk? No. Yeah. So Pamela is engineering this week's episode, but she's like talking to us like the voice of God. It's quite peculiar. I can hear her in my mind. But look at this. Look. No hands. Engineering being done. So even though you won't be able to hear her, thank you so much, Pamela, for engineering today's episode. And it's just making us stronger. Unless it kills us. Hey, guys, haven't seen you for several months. How's it all going?
Yeah, that's going well.
Yeah.
This is dynamic conversation. I'm give me a moment to warm up again.
So the way this works is like two people have a conversation, they talk to each other, and I know we're also used to just being inside our four walls. Yeah, back to doing our job. And Ashley, good to see you again. So now you're regular.
Thank you. Likewise. I'm so happy to be here with you all.
Yeah, and I saw the story that you picked, which is sort of nicely connected to some of the stuff we talked about last season. So I think this is pretty exciting. Pretty stoked on this.
Absolutely.
And Moya, good to see you again.
Wow. Yeah,
Doctor, notice we could fit in the Dr. Moya McTeer into there.
Yeah, the perfect size. It's good to be here.
Right on. So I don't even know how this works now. Fraser friend needed to come over. Okay, I see. You got a background noise to us. Okay. Maybe you can mute your mic, Pamela. Let me see, because it's like a bet. But it's or change to a better mic, because I think you're using like a potato mic. It's super gainy, but unless it's someone else's mic. If she's muted, I still hear kind of a hall. Oh, wait. Yeah, you should definitely mute yourself, Nancy. There you go. Yeah, that took away the sound. Let me just get a mic check now. So, Alan, can I hear you?
Hello, I'm here.
Yeah, and Moya, can I hear you?
Hi there.
Yep, and Ashley?
Here I am.
Okay, great. All right, then I think we're good to start. Let's just do this thing. See if I can remember how to do this. All right, with the whole new layout. Hello and welcome to the Weekly Space Hangout for Wednesday, October 13th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about 42 of the largest asteroids with the Very Large Telescope, DART, climate action from NASA, hearing the Northern Lights, women of color representing, Women of Color Project representing unrepresented women in graduate programs, no oceans at Venus. Wah, wah. So joining me this week, now they're all just on the screen, so it's like no surprise, I guess, but I'm just going to start from left to right as I see them. So there's Alan, there, he's this way. Alan Burstfield. Hey, Alan.
Hello, how are you? Yeah.
So, yeah, I'm assuming since I'm entering winter, you're going into spring. Is that right?
It's starting to feel more like summer. It was 30 degrees Celsius today.
Oh, and, yeah. We had our first frost. We had a hailstorm that dropped hailstones as big as marbles. Which is not right, but we did see the Northern Lights last night, which was amazing.
What did you hear, though, is the question.
I did not, so I'm really into having this conversation. Yeah. So there we got Dr. Moya McTeer. Moya, welcome back as well.
Hello. It's so good to see all your faces.
And how did your summer go?
It went well. I spent most of it writing the book. I just turned in the second draft to my editor earlier today.
Oh man, that's so. So are you going to be like a multiple writer at this point, or is this like the one and only book that you will ever write?
I would love to write more. I have more ideas in the old brain can here.
It's not about the ideas. It's the willingness to sit down and write the words to make the idea come out on the paper. Oh,
Fair.
it's like pulling teeth. What do they say? Like, writing is easy. All you have to do is just bang your head against the computer screen until.
It did feel like that sometimes.
Yeah.
It felt like I was, I have never given birth, but it really felt like I was like creating something and bringing it into the world.
Yeah, and it's rough in the beginning because you're just like, you don't even know where to start. You don't know where are you being efficient? How long is this going to take? And you think you're 90% of the way there, and you're really only 50% of the way there.
Mm-hmm.
Needless to say, I will never write another book. Let's just say that. All right. And rejoining us, we got Ashley Walker. Hey, Ashley, welcome back to the Weekly Space Hangout.
Hello. Thank you. I'm so happy to be here with you all.
And so you were a guest last season, but why don't you give an introduction so people know who you are?
So my name is Ashley Walker. I am an astrochemist, an incoming PhD student at Howard University, and a science communicator, as well as the founder of Black and Astro.
And of course, if you want to learn more about Ashley's background, you should definitely go back into the archives of the Weekly Space Hangout and hear the more lengthy interview that we did with Ashley. But this is awesome. All right, well, let's get into, actually, wait. Before we get into this week's stories, I just want to take a second to thank our good friends, our family at the Weekly Space Hangout crew. They are, we couldn't do the show without them. We wouldn't. And especially Nancy Reziano, who's actually here behind the scenes, listening, helping. So if you want to join this amazing community, see behind the scenes, talk to all your friends about space and astronomy, go to wshcrew.space, and they will hook you up, give you your executive producer credentials so that you too can bring on cool new special guests onto the show. All right, let's go. And so I guess we'll do this again. Alan, you are sort of being able to see you guys all in a line like this is just going to mess with my randomness. So, Alan, what have you got for us?
So, if you've not heard of the DART, what we would say, the DART mission, the DART spacecraft mission, they will be. The news part of this is that they're launching it on November 23rd, I believe. Yeah, 23rd on a Falcon 9 rocket. And well, that's the news part. But if you've not familiar with the mission itself, I think it's really interesting. It's the double asteroid redirection test mission. It's basically a planetary defense system, which is being tried out. And I think, even in popular movies, people talk about how do we avoid an asteroid impact. So there's been some movies about it. It was a very major plot point in The Expanse. And the usual ideas people have are, well, we can blow it up, but then you get lots of pieces, or we're going to try and push it to the side. And this, I think, this isn't part of the popular conversation at all. It's why don't you just hit it really hard and see if we can just bounce it a little bit off to the side. And that's what this mission is testing. So DART is powered with an ion drive. It's going to intercept asteroid Didymos, which turns out to be a double asteroid, primary about 780 meters in a little moonlet of it's about 160 odd, I believe. And just to see how much can we deflect it. And the reason they've chosen a double asteroid is because you've got these two relatively small bodies orbiting each other, and you hit it really hard, and the change in speed is going to be very, very small, but with such light objects, comparatively speaking, it will change the orbit between them. And we should be able to detect the orbital period to change by several minutes if everything goes according to plan. It's being timed for when they are nice and close to Earth, because it is a near-Earth asteroid already. And I assume they've done their maths properly. They're not going to accidentally bump it closer to us.
Yeah. It is funny, though. You're exactly right. I mean, there have been many disaster movies about asteroid impacts, and always you send a deep sea mining crew out to meet the asteroid and to drill into it and to blow it up or whatever you got to do to remove it. But we've never done any kind of actual experiment to see what it's going to take to shove an asteroid off course. And I guess if you have time, if you have ample time, then maybe you can shift it off its course. And over the course of years, what would have been a direct hit is going to turn into a miss. But so they're hitting the moon, right? Are they hitting the asteroid or the moon?
They're hitting the moon.
Right.
Yeah.
I love the. Have you heard the name for like Didymus is the asteroid, and so Diddy Moon is the moon.
Well, I'm glad I pronounced it correctly because I haven't spoken to anybody. I've just been reading it all.
Yeah. But it has another name, but I like Diddy Moon, which is perfect. So when does the mission launch?
It's next month, the 23rd of November.
Yeah.
About 10 in the evening Pacific time. And because the Falcon 9 is launching from Vandenberg Space Force Base in California.
And so are they just going to crash the whole spacecraft into it, or are they going to use an impactor and then orbit to see what happens?
I think they're sending the entire spacecraft in. Yeah, the whole thing is kind of flying at top speed, 6.6 kilometers a second. Lots of clever software and navigation cameras to make sure it hits. And they also, I think they're also using a new type of ion drive to power it in the evolutionary xenon thruster. So NASA evolutionary xenon thruster commercial. So it's Next C.
Mm-hmm.
I don't know if that's been used before. Do you know?
No. So NASA's got like there's ion thrusters on the Dawn mission, on and then the JAXA missions, but they've been working on these next level propulsion systems from NASA, and I think this is the first time they've prototype tested this version, which is great because they're I forget exactly how much it's still like it feels like a piece of paper on your hand, like the amount of thrust that these ion engines are putting out, but still it's kind of impressive how much stronger and more powerful they are. But they need a bigger energy source. But that's great. That's awesome. So I guess, do we know like how much can we expect it will move? What's going to happen?
I don't know that we will see it move directly. The orbital period is going to shift a little bit. I mean, a little spacecraft like this isn't going to be that heavy, and a 160-meter chunk of rock is going to be quite massive. So the deflection is not going to be very high, but it should be enough. Such light objects, it doesn't take much of a change in velocity or mass to make a measurable difference in the orbital period, and they're expecting it to be several minutes. So they should, I don't know if it's going to slow down or speed up, but one of the two. But that'll easily be measurable, especially since they're observing with radar and ground-based radar to measure that.
Yeah, that's really cool. Right on. Awesome. Thanks, Alan. All right. Sure. Moya, what have you got for us?
Do you want climate or auroral sounds first?
Well, okay. So I just saw some wonderful auroras last night. So I didn't hear anything. Why not? Should I have?
Probably not, actually. They're pretty rare to make sounds, and I'll get to why in a second. But for those of you who don't know how the aurora borealis works, also called the northern lights, they're caused by interactions between Earth's atmosphere and charged particles coming from our sun. The particles get caught up in Earth's magnetic field lines and get carried to the poles, where they get concentrated, so you get these beautiful visual displays. You can probably think of aurora, or you probably think of them as solely visual phenomena, but people living in northern settlements have reported hearing sounds from the aurora borealis for hundreds of years. We have reports, like written reports about this going back to the 1800s. In the 1930s, several people testified to the Shetland newspaper, these are the Shetland Islands off of Scotland, that they heard something that sounded either like rustling silk or buzzing or humming or whistling coming from the aurora. These reports were corroborated by people in northern Canada and Norway, but the scientific community was skeptical because few Western explorers claimed to have heard the sound. This is kind of typical for Western scientists. Oh, none of us have seen it, so it must not be a thing. Um, there, oh, I lost my place. So they assumed that people were just imagining the sound, maybe something in our brains. We see the aurora, and so our brain makes up a sound kind of similar to how if you see a meteor or a shooting star, your brain might imagine a whooshing sound. There were also some scientists who claimed that all those people in the north, they were just drunk and hearing things. but but the belief was that aurora happened too high in our atmosphere to produce any audible sound because they're usually above 100 kilometers from the surface. But in 1923, a well-known Canadian astronomer named Clarence Chant suggested that the interaction between solar particles and our magnetic field changes the electrification of our atmosphere. So the charges are different than they usually are during the aurora, during a strong one. And even from 100 kilometers above the ground, when those electrified particles interact with stuff like trees or our clothes, they create a little bit of static. Unfortunately, Chant's work didn't get much attention until 50 years later in the 1970s, when scientists were discussing this more. And then it took until 2012 to get the first ever recording of one of these noises. This was thanks to a Finnish acoustic scientist named Unto Lane, who spent 15 years studying the aurora and the sounds that they made up in the northern latitudes. He kind of confirmed that Chant was right, that it is due to electrification in an inversion layer in our atmosphere about 70 meters off the ground. So good job, Clarence Chant.
Meters or kilometers? Sorry.
The article that I read said meters, but that might have been a typo because that's real close.
That seems real close, yeah.
Yeah.
That's like just still crackling over your head. But it makes sense that you would hear it if it's that close. But yeah.
Exactly, yeah. If we are going to be hearing it, then it should be close. And that's not where the aurora happened. That's just where the charged particles that create the static are. But these sounds are only produced by the strongest aurora, maybe about 5% of them. So when Lane was doing his research for 15 years, he experienced a full solar cycle, and he couldn't really get any research done when the sun was at its magnetic activity minimum. And then he then did hear it in around 2011. So he could produce it and publish it in 2012. But if you're ever lucky enough to find yourself standing under the northern lights during an especially strong solar flare, take a moment to close your eyes to the beautiful sight, even though it may seem pretty counterintuitive, so that you can count yourself among the lucky few who have heard the northern lights.
So we saw them last night, but they weren't great. They were over the horizon, a green glow, and I was able to take some pictures and get a better green glow and a bit of a purple glow. A couple of years ago, we got one that was like the king of all northern lights, where we're just like half the sky is filled with dancing ribbons, and it's just blowing your mind. And I wonder, I mean, we didn't hear anything for that, but it still felt like it was pretty far away. But I know that when you're in places like Iceland and stuff, then you actually get them directly overhead. Well, it looks like sheets from our perspective, looks like snakes in the sky directly overhead, and I'm guessing that's the time to see if you can hear. So have you ever seen the Northern Lights?
No, I never have, but I would love to. My fiance and I are starting to think about honeymoons now, and one of my top choices, the one I'm gunning for, is to go to Iceland so we can see the Northern Lights.
And especially now, I was there 3 years ago, and like closing in on solar minimum, it was rough, but now as we're sort of shifting out of solar minimum, now's the time. But even like you're like in the northern US, right? You should have seen the ones that we've been having for the last couple of nights.
Well, I'm in New York. You can't really see anything.
Yeah, I guess you can't. You can't even see stars in New York.
I know. You can see Orion if you're lucky.
Right. Yeah. It'd be worth it. Like with this level, like the activity was pretty clear that it was happening, and with that amount of activity, I would make a road trip. It was like, I know people across all of the northern U.S. were seeing it, so I'm sure even in New York, if you got to know where you're closest dark skies are, but I'm sure it's still like a rental car and a 5-hour drive away.
Yeah,
So
definitely worth it.
yeah, the same place you go for the Perseids, of course.
Of course, which I still haven't seen.
Maybe I'm just rubbing it in then. That's awesome. Thanks. All right, Ashley.
All right, so I'm gonna talk about the Women of Color project, but
Sure.
I am gonna tell you all with this Venus drama, I believe TV show, but we're gonna get to that a little bit later. With the Women of Color project, it was found in 2019 by Miss Linnell Williams of Harvard University, and so she came up with this amazing idea to continuously support Black and Brown women and non-binary folks who identify as such, and wanting to make sure that they'll get to and through graduate school. And so I'm being biased because I was a part of the first cohort. So every year,
Fine. We accept all the log rolling for sure on this show. Yeah, feel free to shamelessly self-promote the projects you're enjoying.
So every year, her and her team continuously do so, which I'm still a part of the team. And this year, I was on the non-traditional route for graduate school panel. So this amazing event, it's a workshop which takes place during this past weekend, as I mentioned. And initially, it was in person, and thanks to COVID, now we've moved to online. When it was first brought on in person, it was a sense of community that most women of color don't necessarily get. So you're in a room with women that look like you that kind of face some of the similar struggles, and you're also meeting people who want to make sure that you succeed, and how can we help you get to the next level. But since COVID, it has turned into an online platform,
Mm-hmm.
which still embraces the same values and core beliefs, and also um, just an array of a great support group. And if I'm not mistaken, Moya, you were there last year, correct? I think she was there last year.
Moya, I don't know if you were catching that. She was asking if you were at the event last year. Are you
So-
muted? Maybe.
I can't hear Ashley for some
With this
reason,
being
but
said-
I wasn't at the event, unfortunately.
That's weird. Okay. All right. Uh-oh. I can hear you though, Ashley. Keep going. Oh, I wonder if she's starting to disconnect.
So with this being said,
Yeah. So we can still hear you, Ashley, but your video's frozen. So maybe it'll recover.
oh, okay. I didn't know. I knew I froze, but I didn't know if you could still hear me.
Yeah, we can still hear you.
The one, yeah, it's still, it's been just this amazing network, and so we want to make sure that we continue going.
No, you're definitely losing you. I'm losing you. Maybe the audience is hearing you. We all lost her. Okay, all right. Okay, well, we'll see if we can get Ashley back and continue that conversation. So I was going to mention just briefly. Oh, she's there in the text, but you're just like a blank void in our windows, Ashley. Yeah, try disconnecting from the rendezvous and come back in if you can hear us. So James Webb arrived safely at French Guiana. So this happened just a couple of days ago, and the James Webb pulled into port at the spaceport at French Guiana. Of course, the reason why James Webb didn't fly down to the European Space Agency's launch port in South America is that it is too heavy for all of the bridges from the airport to the launch facility, and so they had to make this decision: do we want to rebuild and upgrade all of the bridges to be able to handle the weight of James Webb as it is trucked from the airport to the launch facility, or do we want to take it by the ocean, braving pirates and whatever mayhem? Who knows what it might find as it goes through the Panama Canal, etc. And
those would be some gutsy pirates.
well, it's a $10 billion payout if they get it. So, although I'm not sure who would buy a black market James Webb Space Telescope.
Right. What's the supply to the demand
exactly.
for that?
Yeah. Anybody, you want to buy a space telescope? Maybe. So they, but anyway, so they did, and so NASA was actually totally secretive about the whole route because they didn't want to have anybody find out and sabotage it or pirate it, and so yeah, pulled into the facility. So all of the other parts of the rocket have also arrived. The upper stage has come in. I think the lower stage is in. This is going to be launching on an Ariane 5 rocket that's been, I guess, that the European Space Agency has had prepared for this purpose for, I don't know, 1,000 years, waiting for James Webb to be complete. So if all goes well, James Webb will blast off on December 18th, 2021, still within the current year that we exist, about 64 days from now. And then it's going to take about a month to get out to its final operational orbit, deploying dozens, if not hundreds, of actuators, putting out its sun shield, deploying its main mirror, and all of the other parts. So this is it. If you've wanted James Webb to launch already, we are getting very close.
How does it feel to know that this is just half of the stress, all of the stuff we've gone through with James Webb up to this point?
So last week, Kimberly brought up this idea of the 30 days of terror. And so Nancy Atkinson on Universe Today, she wrote up a story about this and sort of detailed the 30 days of terror that they're going to go through. And she actually had a chance to interview a bunch of the different people working on James Webb. And she's just got some juicy quotes from these poor engineers and flight managers and so on who are going to have to, with Curiosity, 7 minutes, you could almost not breathe for the entire 7 minutes. But with James Webb, you go home, you eat dinner, you go to bed, you wake up the next morning, you're still terrified, you go all day long. The three actuators that you're watching are slowly pushing out. Everything's okay. Yeah, and then you go home, and then you're wait, and then you maybe get a call in the middle of the night because one's a little stuck. Oh, it's just going to be it. Yeah, I know. And also, I saw a great name on the internet because, of course, the name for James Webb is now in a little bit of controversy. So someone proposed the Very Cold Space Telescope, which I thought was a very good name. So maybe we'll just use the Very Cold Space Telescope from this point on. Supposed to James Webb. Ashley, how are you doing? Are you back? No, she's still just a prisoner of bad Wi-Fi somewhere. Mm-hmm. Yeah, we see her, we see her in the chat, but again, just a blank void where Ashley should be. All right, so let's come back around and talk about your other story.
Yes, so the ESO announced a little while ago. Oh, I got some.
Well, I'm getting an echo from Nancy. Yeah, okay.
Okay, yeah. That confused me. So am I coming through?
Yep.
Okay,
Yeah,
great.
there
So, yeah, I'll start again. ESO, who run the VLT telescope in Chile, they've recently announced the end of a survey project to map some of the largest asteroids in the solar system, starting with Ceres and Vesta, going down to objects a little under 100 kilometers in size. And these are what they've got is these high resolution images where, for many of them, I think for the first time, we now have a solid idea of exactly the shape of these objects, which in turn means that for the first time, we now properly know the density of them. Because if you can't tell if something's a sphere or a long thin object or what have you, and what it's revealed is that the density of these objects varies a lot. Some of them quite light, a little over 1 gram per cubic centimeter, which is like coal. Some of them more close to diamond. And that seems to suggest quite strongly that these asteroids have all formed in different areas of the solar system. That they've come from all over the place and been herded together, which puts paid to the old idea that maybe this was, I don't know if anybody was still teaching this, but the idea from when I was a kid that the asteroids were a planet that never formed. It certainly doesn't seem to be the case now. This is one more nail for that idea.
I want to figure out a way that I can share that image because it is stunning. The resolution. Sure. Let's see. This is more engineering than I think you signed up for, Pamela, but no problem. Yeah. So hopefully we can see the images, but it's just the resolution on 42 asteroids. Each one looks like a little rocky ball in space, but they're like different shapes and stuff. I can't believe that this was done with a ground-based telescope.
Yeah, I mean, some of them are round as you'd expect, Ceres and so on. It's basically a little sphere. And others are, I mean, there's one, they actually put out a separate press release just for this one. It's asteroid Cleopatra with a K. They describe it as being shaped like a dog's bone. Looks more like a collarbone to me with, all the years of medical training that I don't have. But this thing it's 270 kilometers long, and that's a huge object to not be spherical, right?
Yeah.
And it's this long, thin object. Reminds me a bit of what was
Oumuamua.
Yeah, that's
there
the
it
one.
is.
Yeah.
There we go. So Pamela's put up the pictures. Yeah. Although you can't see Cleopatra in this set. So
I think it's one of the smaller ones near the bottom.
Yeah. But there we go. There. See, there's Cleopatra down at the bottom now. But yeah, like look at these asteroids. Each one of these is a world taken from the surface of the Earth. Like this is the kind of picture you'd expect from an orbital mission. So the fact that this is coming from the Very Large Telescope is just astonishing.
Yeah.
I saw this.
With that.
I couldn't believe my eyes when I saw this.
Yeah. I'm still struggling with that 270 kilometer dog bunch. I mean, 270 that's pretty small as planetary objects go and things in space. But if you think about it, what's that about? A little over 150 miles? That's drive that distance twice from here, and I'm in Durban. It's a long way.
Yeah.
It's a big chunk of real estate.
Yeah.
Yeah.
Well, you always think about like space is just 100 kilometers up. Like if you could drive your car, you could be at space in an hour.
Yeah.
If you could just drive straight up. That's all. That's amazing. So was there anything sort of special about the technology? Did they do anything special to try and capture these images of the asteroids?
Now you're asking the tricky questions. You're testing my homework. What I can say is that this was a survey done over about 2 years. They finished in 2019, I believe. And they're hoping to go a little bit deeper to smaller objects in the future.
And so, I mean, surveys are great because they tell us like large answers about entire populations, in this case of asteroids. So did we learn anything about the overall asteroid belt from this research?
I think the main thing would be just the variety of different compositions of the asteroids. With such a wide range of densities, they're obviously not all the same. They're not made of the same stuff. So the working theory now is that they didn't all form together. They're not made of the same things. So you've got two distinct populations which seem to have come from different regions.
Right. Yeah.
Yeah.
I mean go ahead.
Because there's a distinct break between the spherical ones and the lumpy, distorted shaped ones. Which then boils down to the different densities as well.
Yeah. It's again, I mean, the science is cool, but I mean, just the fact that they were able to take these pictures just is so wonderful. I just love it.
VLT is
really
an amazing
awesome
instrument. It really is.
And think about it, right? Like, this is wait for the extremely large telescope to come online in another 5 years from now. It's going to be a 39 meter telescope as opposed to 8.2 meter telescopes. Like, it's going to be some next level pictures. Like, and it's going to take pictures. It's Swiss Army knife. It'll take pictures of everything, asteroids, supernova, you name it, planets orbiting other stars, everything. Very cool. Do you think? How much time?
With less than 10.
Yeah, didn't they say with the, like, they didn't want it because it was going to cost $1 billion, so they decided not to build the overwhelmingly large telescope?
That's a fraction of a James Webb.
I know. That is the joke we always make. All right, well, Moya, you're back. What else have you got for us?
I have information about NASA's climate plan. So last Thursday, on October 7th, NASA released their Action Climate Plan. It's just one of 23 federal agencies that are included in this plan, which takes a whole of government approach to tackling the climate crisis. And the other agencies are ones that you would expect to be in this, like the Department of Energy, the Department of Agriculture, all of the departments that seem to exist in the environment that are affected by climate, which is all of them. Of these agencies, NASA is one of the few that actually conducts its own climate research. They study ice loss, ozone depletion, sea level rise, extreme weather changes using satellites that look back at Earth. But NASA has an especially vested interest in solving the climate crisis because apparently 2/3 of NASA assets are located within 16 feet of mean sea level along America's coast. This is according to the action plan that they just put out.
Right.
And those assets are, like their launch pads and the research centers and like a lot of storage facilities, I'm also guessing. But those things are particularly vulnerable to sea level rising and damaging weather with more extreme hurricanes and climate change that gives you temperature swings that you might not be used to in these regions. Their plan includes 5 different priorities, 5 different areas of focus. The first is identifying aspects of climate change that threaten access to space. That makes sense. One of NASA's big missions is to increase access to space. And right now, air pollution and light pollution currently impede about 80% of humans' views of the night sky. That's according to the World Atlas of Artificial Night Sky Brightness. And that definitely impedes access to space. Their second priority is integrating climate risk analysis and adapting those procedures into NASA's overall plans. So I guess the second priority is do good climate stuff. The third priority is
thanks, doctor.
Yep, you're welcome. That's why they gave me the fancy
Yeah,
paper.
exactly. That's the technical terminology we've been hoping to hear from you.
I'm sorry. The third priority is implementing the climate resilience strategies that they research. So how can they not only do more climate research, but how can they make sure that the facilities they already have are less vulnerable to climate change? The fourth priority is developing the next generation of climate models. This is going to be really helpful because climate models can help us predict climate change in the future, maybe even help us stop it or slow it in its tracks. And then the fifth priority is partnering with aviation and aeronautical organizations to reduce carbon emissions and maybe even do some research into how you can kind of scrub carbon from the atmosphere. So, not reduce your emissions, but do kind of reactive work to get rid of the emissions that have already been made. Members of the public can submit their feedback to this plan. So you can actually comment on NASA's plan. You can comment on the other 22 agencies' plans as well until Saturday, November 6th. There's a link here, and Fraser, if I send that to you, can you share it out somehow?
Yeah.
Cool. Yes, I will put it in the chat here because I want everyone to be able to find a way to comment on this. It's something that we will all feel the effects of, us people who are interested in space. So you should get your voice heard.
The irony of this whole situation is kind of frustrating because if there's any one agency that has been going on and on and on about climate change, it is NASA. And here we are now, NASA, with so much of its operations on low-lying coastal areas, suffering from these kinds of climate effects, and now they're having to of course, the Kennedy Space Center out in Cape Canaveral is going to have some problems when the ocean levels rise and the erosion increases, and now they're having to deal with the outcome, and they've been warning people for Dr. James Hansen has been warning people for 30 years at this point, and now NASA has to pay to deal with the repercussions of climate change, and not just NASA, of course, the rest of us. But
yeah, I feel like every other month or so I see something saying it's going back and further back in time, the 1960s we knew about climate change, the 1920s,
exactly. Genghis Khan warned us
right
about climate change in the 1200s. Yeah, absolutely. I think I've seen one in the 1800s. Someone had done the math. Literally, as soon as someone discovered carbon dioxide, they realized that it caused a greenhouse gas and had made these kinds of predictions. Because it's a fairly simple experiment. You can just pour carbon dioxide into a aquarium and watch how the temperature goes up. It's not that complicated.
Really not.
It's just the actual specifics of what happens when you have an ocean and mountains and so on. But overall, in fact, I interviewed, was it Michael Mann a couple of years ago, and he was saying literally you give a high school student the formula for calculating what happens to temperatures with the greenhouse effect, and you can predict perfectly the overall impact of climate change on Earth. You don't need, obviously, what matters is how's it going to affect the coast and how's it going to affect the Arctic but the overall just temperature change of the volume of the Earth's atmosphere, the warming effect from carbon dioxide, it's relatively straightforward to calculate in broad strokes. So madness. So was there anything out of this, sort of these ideas that kind of leapt out at you? Was there anything that you were was interesting to you?
I'm excited about the climate models. I took a class on climate modeling in grad school, and it was really cool. One of my cohort members did research with GISS to see how she could model the climates of exoplanets based on different rotation periods of the planets and their albedos. And I'm just excited to see more accurate models here on Earth. I feel like a lot of, maybe this is just optimistic of me, but I feel like if we could somehow get a convincing enough and understandable enough graphic or video, like something that really shows what's going to happen, then maybe people will start acting. Am I too optimistic?
Yeah,
Yeah.
but yeah. But I think the yes, that's the the planet simulation system that NASA built. Yeah, is that the same one that lets you like simulate like Venus at different times and Mars and other worlds? I mean, that's part of the. I mean, of course, we're dealing with the unfolding tragedy of climate change here on Earth, but being able to understand, and that's why Ashley not being here, it's too bad, because this is exactly what she was going to be talking about. There's this research that dropped today about people did some climate modeling of Venus right back to the early stages and found that based on their models, Venus never had liquid oceans. It's impossible for it to have ever had liquid oceans. And so life just could not be possible on Venus, which is the exact opposite of the research we heard fairly recently that NASA had said, in fact, Venus probably had oceans fairly recently.
Yeah, I remember that.
Yeah, and so what they did was they took into account essentially the fact that the sun was less bright in the past and has been increasing in heat, but even back sort of when Venus formed, the sun was, say, 30% fainter than it is today. But they found that this still caused very high surface temperatures on Venus. And because of those high surface temperatures, it created a lot of clouds, and those clouds raised the temperatures even more, prevented any rain from falling, allowing oceans. And without oceans, you don't get liquid water on the surface of Venus. Without that, you have a really hard time. So even though Venus was probably cooler than today, as soon as that heat kicked up all of the cloud formation, and yet also it was too hot for it to be able to come down as rain, it was game over for life on Venus. And so, but this is like models that they've come up with, and so we're sort of, it'll be interesting to see. They want more supercomputer time and to try and test those out and see where the this still holds. But if so, I mean, another great reason why we need to have another mission, something a little longer lasting, something that can go into the atmosphere of Venus, a balloon mission that can sample the atmosphere, something that can go to the surface of Venus, try to look for any kind of evidence of past water. I mean, look at how hard it's been to find evidence of past water on Mars. Imagine trying to do that on Venus. Yeah. So, and
things don't melt as soon as they reach the surface of Mars.
Yeah, exactly. Yeah. So it's tricky, but theoretically possible, and yet could tell us a tremendous amount about how we differed from Venus, how, we've got a pretty good sense now of how Mars was different from us. And that would give us so much information about the habitability of exoplanets out there, because I think it's sort of assumed that at various points in history, Venus, Earth, Mars, they were all wonderful. But now it looks like, yeah, that's what I heard too. Yeah. But now the word on the street is Mars. In fact, there was a similar paper about that as well, about Mars sucking as well. That it was never really that habitable either. It was just too small, dried up too quickly, just couldn't hold back the solar wind, and so.
I'd be interested to see what factors went into these Venus climate models, because I feel like so many of these models ignore what happens inside the planet, tectonic plates and carbon cycling and all of that, which really can make a difference. So I'll be reading that paper after this.
Well, I'll give you so I just linked you the paper, or linked you the press release, and then you can take a look at the paper from there. So I know you I'm assuming like you're just collecting every world building piece of material you can get your hands on.
Yes, I am.
Yeah, that's awesome. All right. Well, I think we're nearing the end of our show. Unfortunately, Ashley just has gone over the event horizon and we've lost her, but hopefully we'll have her back at some point in the future. So let's, speaking of shamelessly self-promoting things that we're working on, Moya, what are you working on and where can people find out more?
You can follow me on Twitter. I'm GoAstroMo, and that's the best way to keep up to date. But I just turned in the second draft of my book. That's called The Milky Way, an autobiography, coming out next August. I host a podcast called Exolore that's all about fictional world building. You can find it wherever you want. EXOLORE. It's Exolore Pod. And I'm doing a live show all about the worlds and world building of the Stargate franchise at Caveat in New York City on November 2nd. You can buy tickets in person or live streaming, so you can watch it wherever you are if you're interested.
And like you're gonna like do a show in front of an audience?
In front of an audience on stage?
Of other human beings? Wow, that's brave.
Very exciting. I did one on Saturday. It was the first time I had been on stage since before the pandemic, and I felt so powerful. It was great.
Powerful? I feel like you just feel terrified. Like, I don't know. Like, we've all just gotten so fearful.
Yeah.
So I think it's great that you were able to give a talk and you didn't get the COVID. So.
Right. I've been tested since. No COVID.
Oh, good. Yeah. Alan, what are you working on?
I've been promising this for so long now. Episode 61 of the Urban Astronomer podcast is finally on its way out the door.
Nice.
I don't feel too bad. James Webb has been going for what, 20-something years? A long time. So
right. So you could still be another $9.9 billion over budget on producing this, and you'd be all right.
Yes, and I'm totally comfortable comparing myself to the James Webb Space Telescope.
Yeah, perfectly reasonable comparison. Yeah. What's the topic?
It's an interview with somebody who's doing a PhD at 2 different universities at the same time on astrophysics, which I didn't know was possible. I must actually catch up and find out if she's graduated yet, because I recorded this interview more than a year ago.
Maybe she's gathered another 2. You don't know.
Yeah. She's split between University of Cape Town and, I've forgotten. I think it's, I'm not even trying to pronounce it. My Dutch isn't very good, but in the Netherlands.
Right.
Groningen, I think it is. Very interesting conversation I had with her. And I can't wait to finally get this out there.
That's awesome. Well, if people want to follow what you're doing and they want to subscribe to your podcast, where should they go?
Start at the podcast websites, urban-astronomer.com. There's subscribe links to all platforms on there, or just search for the Urban Astronomer podcast. And you can follow me on Twitter at @uastronomer.
So I'm going to forego my shameless self-promotion, and instead I'm going to shamelessly self-promote the Hangout-a-thon, the CosmoQuest Hangout-a-thon, which is coming up October 23rd and 24th. I just dropped my phone on the ground. October 23rd, 24th, so just like a little over a week. And it's, of course, a grueling multi-hour event where Pamela and the rest of the CosmoQuest team entertain you with all kinds of interviews and science presentations and games and music and all kinds of good stuff. And the goal, of course, is to raise money for all of the amazing work that's being done with CosmoQuest. So if this kind of science outreach is important to you and you want to play a part in it, or even just come and hang out or help us get the word out, go to cosmoquest.org and you'll find all of the details. Now you can donate early and donate often. So already, if you want, you can contribute to the Hangout-a-thon and help them reach their goals to fund everything that CosmoQuest does for another year. Remember, this is the team that brought you such highlights as analyze rocks on Osiris on asteroid Bennu and count craters on Mars. So if you want to see more of that cool citizen science outreach, come join us at the Hangout-a-thon. And I'm sure 36 hours straight, says Pamela. So that is the marathon that will happen. And I'm sure I anticipate being brought to bear at some point during the Hangout-a-thon as well. But this is it's a good cause, So like I said, donate early, donate often. All right. Well, thank you everybody for joining us this week. It's the new format. Please give all of your feedback to Pamela, I guess, if you want to make any changes. I love it. I get to just sit here. It's the best. So again, thank you so much, Pamela, for all of the work you're doing behind the scenes. Thanks, Nancy, for organizing all of us and helping bring the Weekly Space Hangout another year. Thanks to my co-hosts, everyone watching, all of the moderators, and Ashley. We will see you. We will send a search party, and we'll find you. We'll find you for a future week. Thanks, everybody, and we'll see you all next week.
Bye-bye.